All right, the way that I start off most units now, as we get deeper into the year, vocab won't be so necessary because we'll already have talked about it. But this is some vocab, and the vocab is actually there to help you understand if I say something like dependent variable, that you're not like, what the heck is he talking about? And if I say something like that, I would check the vocab right off the bat. Now, I do not have what's called a vocab test or a quiz, but I will integrate these into the test and quiz, and I'll expect you to know what they are. But I'll throw these up on the review again. So let's go past the vocab, which is quite a bit there. And this link right here, right now, will change. Of course, if you're watching the video now, it probably has been updated, but that is where I'll actually have the link to the videos. I'll probably find another place to put it so it's a little more accessible, but I will generally at the beginning of the material put the link for the video, and also it'll tell us what the homework is. So the first part here is scientific method. This is something that you've heard 1,000 times in every single science class. It's generally the first thing that we talk about. The thing that I want you to get out of this is the process. In other words, since this is a science class and chemistry, there are some things that we'll do, not necessarily while we're sitting here listening to a lecture, but while we're in a lab. So we'll take some observations, and this is things that you do in everyday life as well. You see something, you base a hypothesis on something. So you're like, oh, the door is over there. And then I can hypothesize that it is strong, it is made of wood, etc. I can do things like that. And then I might perform some experiments as easy as walk over and knock on it. Confirmed. Okay? And if it's confirmed, then I can say that it's a law. Things like that. And that's a very oversimplified explanation to what scientific method is, but we do it every day. Okay? If I go over and I hit it and it breaks apart, then I have to reformulate my hypothesis. And that's what we'll do in here somewhat. Here are some sciences, some chemistries actually, and this chemistry that you're taking right now, I call it baby chem, okay? And don't take offense to that because we all have to start from the beginning. And then once you take baby chem or general chem, then you'll branch out into others, and they get more specific. Like I had a class at Avon called organic chemistry. And organic chemistry, and I have blanks here, organic chemistry is a study of carbon. Okay? So when you get into organic chemistry, and I hate to say this out loud, but organic chemistry for most of you will be the most important chemistry you ever take. If you want to be a doctor, a pharmacist, something along those lines in the medical profession. And organic chemistry is vital because that's what makes us up. We are full of organic compounds. We deal with organic stuff. Our medicines typically are organic. They have these fancy names. The class that you are now taking right now, baby chem, is an inorganic chemistry class. In other words, it deals with things that are not associated with carbon. Now, we'll sprinkle in some carbon every once in a while, but it is, I like to just say, not carbon-based. Okay? So these are more industrial type things, like if you're talking about, like if you want to build a car and you want to figure out how strong the metal is, that's inorganic chemistry. Biochemistry takes the love of biology and chemistry and brings it together. So it's kind of a branch off of organic. And a lot of you, if you go in the medical profession, will take biochemistry. And this is where you study biological processes with chemistry. Okay? So this is life chemistry. Okay? Analytical is another type of chemistry. Like if you get a solution and you're like, what's in it? You're going to analyze it. Okay? So that's what analytical chemistry is. And then physical chemistry is kind of a branch off of inorganic. Now, I'm going to tell you right up front, you don't need to know those types of chemistry. I'm just throwing those out there to let you know what's available. And that this chemistry and AP chemistry is not the only chemistry that exists. There are so many branches of chemistry that it could take us hours to talk about, which I'm sure would be exciting for you. Again, some more of the problem-solving techniques. I'm not going to go over that. I just kind of talked about it. So we'll analyze the situation, we'll calculate it, and then we'll evaluate. We'll talk more about that when we get into the labs. Mathematical knowledge. Okay. So I'll sprinkle in some holes every once in a while, just to kind of keep you on top of things. You may not realize this, but you just took a math class by signing up for chemistry. And again, I think I may have talked about on the first day that if you're good with algebra, it's going to be a piece of cake. But again, if you're not strong with that, let me know so we can work things out. Again, we talked about observations, so we will make a lot of observations in this class. And again, we need to know our skills with math or mathematics. We're going to deal with some measurements in here that deal with length, mass, and temperature, and you'll get to do all of that at one time or another in a lab. So that's pretty exciting. You guys have the blanks for that? Okay. Oh, come on. Where'd the pen go? Okay. Actually, let's just tap it. Also, I may have used this as an example when we talk about quantities. I can't remember, and again, I've got so many classes. If I were to tell you how much I weighed, I think I weigh about might be 109, might be 110 now. Would you agree with that?
No.
Why are you shaking your head no, Taylor? You say I'm fat? No? That's a good answer. Now, you guys are thinking about pounds. What am I actually using? What unit? I'm using a mass unit. Kilograms. Each kilogram is 2.2 pounds. Okay? So whenever we talk about numbers, and that actually goes along with this, no naked numbers, because sometimes we assume that everybody knows what everybody else is talking about, but unless you put a unit on there, there's no confirmation. So when we talk about quantities, we don't want to have a naked number. And a quantity actually is identified by its unit. So when we talk about it, make sure you tell me a unit. Because again, a number can refer to anything. Okay? And until we know exactly what it's referring to, it means nothing. Okay? It's important to note that like quantities can only be added or subtracted. Let me give you an example. Tell me what the answer is when I have 12 feet plus 7 pounds equals what? Exactly. So when we talk about added or subtracted to like quantities, we have to be talking about the same thing. Now I could say, okay, what is 12 feet plus 3 inches? We would have to convert one of those to the other, and then we could add or subtract. Okay? Scientific notation. Where'd my thing go? Okay. Scientific notation. We will use scientific notation in here, and actually we'll get some practice. Oh my goodness, the smartboard is extra special. Okay, has everybody used scientific notation in the past? I hope. In other words, it's a shorthand way. Say like if I had 1,000 or 156 and then all these zeros here, we would simply write it as 1.56 times 10 to the 11. In this case, I would move, say, the decimals here. I'm going to move it over however many times until I get to the value right in front of the first number. Okay. So we'll do some examples here in a little bit. And little known fact for your calculator, if you have, say, a Casio, or I'm sorry, a TI, the scientific notation button is your EE button, and it's like a second shift here, and we'll talk about that when we do some calculations. On the Casio, it's a little nicer. It actually has EXP for exponent. So we'll deal with that here in a little bit. Okay. And part of when we're working in class, if you don't know how to use your calculator, ask me, because when it becomes test time or quiz time, I will not help you. You ask me during class so that you know how to use your calculator, and for the homework as well. Okay. All right, so here's some practice problems. Okay. So let's write the following numbers using correct scientific notation. Okay. How would I write A? So 8.37 times 10, and how many times do I move the decimal over?
10.
So I go 3, 6, 9, 10, right? 3, 6, 9, 10. So we always want to move the decimal over until it's just behind the other one. Okay? Oh my goodness. Okay, how would I write B? What is it?
4.53.
4.53.
-6.
Very good. Since we're going to the right, we're going to have a negative. So negative, oh boy, 1, 2, 3, 4, 5, 6, 7, 8. Is that what I heard? Negative 8?
It's 8.
Okay. So times 10 to the negative 8. Okay. So again, you're moving a decimal until it's just behind the first number. Okay. Or to the right of the first number. All right. Okay. What would C be? Oh, not your homework. My goodness. How would you write C? In scientific notation. 2.00 times 10. How many times do you move the decimal? 0. Anything to the 0 power is equal to 1. Okay? Anything to the 0 power is equal to 1. Even units. So when you get into AP chemistry and we have a unit and it has a 0 on it, it goes to 1. The unit goes away. Okay? It's a simple rule. Wow, this thing is touchy. Okay. And the last one, the last example, how would I write that one? 8.33 times 10, negative 3. Okay, everybody good with that? Good. The ones that are part of your homework. Think you could handle that? Okay, but don't do it now. You always want to have homework for home. Duh. All right. Now this is going to be fun. You'll love this. In chemistry, we don't use, well, actually, let's back up. In America, it's good to be the king. It's good to be a world power. Because when you're in charge, you get to make up your own rules. In other words, everybody but the United States uses kilograms, meters, liters, all that stuff. We, and I don't know why, but we still use pounds, miles, all that. That's garbage. So the scientific world, at least, will use the metric system, or I'm not good at French here, le system of international, but the international system. So we'll leave it at that. And some of the things that we're going to have to know, especially in chemistry, are our basic units. Like for length, you have meters. For mass, it's in kilograms. Typically, we'll work with grams, and then we'll deviate from that. Good news is time doesn't change, still seconds. Kelvin, when we talk about gases a little bit later on, that'll make more sense. And don't worry about the mole, which is a furry little critter right there. Okay, so those are the SI units for the things that we're going to be dealing with. Now tomorrow, I believe it's tomorrow, or Wednesday, looks like Wednesday, we're going to be doing what's called conversions. In other words, if I ask you, okay, if I have 1 meter, how many centimeters are there? Okay, don't answer that. Or if I had, say, 1 mile, how many kilometers is that? So we'll get to do some conversions, but that's not for today. However, see this here? Some SI prefixes. I want you to know all of these by tomorrow. Okay? In other words, I want you to know actually the factor, and I want you to know the abbreviation. Think you can do that? What time is it? 13? I'm gonna bet by 8:17 today, you're gonna know them all. How much you want to bet? Anybody got any money?
My grade.
Huh?
My grade.
Your grade? Okay. So 817. Do this. Are you memorizing? See, you're terrible. You always wait for the last minute, so you're out. Let's see, who's Brigham?
Okay.
Your grade is based on what Brigham learns.
Is that fail on purpose?
No. I'll give you a piece of gum, Brigham, if you get this. Crap. Time's running. We're running right now. Okay, here, let me minimize this. Still 813. All right. Are you guys memorizing this? Okay. What happened? Oh, it's 8:14. Are you getting it?
Yeah.
All right. Probably about 12 years ago, I had a student who is now a dentist, gave me a saying to help memorize this. His saying was this: the great mega king one day caught me microwaving nasty pizza. Okay. The great mega king one day caught me microwaving nasty pizza. Say it to yourself. The great mega king one day caught me microwaving nasty pizza. Okay. Now, when we write these values here, what did we say 10 to the 0 is equal to? 1. Okay. So anything to the 0 power is equal to 1. And then what we're going to do is we're going to go 10 to the negative 1, 10 to the negative 2. So you're going 0, 1, 2. And then from here, we just go 3, 6, 9, 12. Okay. So you've got wherever 1 is, anything to the 0 power is 1. I'm sorry, yeah, 0 is 1. And then we have our negative 1, negative 2. And then from here, we just go negative 3, negative 6, negative 9, negative 12. And then the other way is 3, 6, 9, 12. Okay. The great mega king one day caught me microwaving nasty pizza. Start at 1 and go 0, but go negative 1, negative 2, and then 3, 6, 9, 12. 3, 6, 9, 12. 3, 6, 9, 12. Say the same.
Me?
Yeah.
The great mega king one day caught me microwaving nasty pizza.
Okay, now microwave, this is a Greek letter, micro. I don't know if it's new. I don't know what the name is, but that's a symbol for microwave. Okay, it's not a M. It's kind of like a U that's got a really long tail in the front. Or I don't know what it is, but I don't know. Say it one more time.
The great mega king one day caught me microwaving nasty pizza.
All right. Do it.
Oh, okay.
It's game time. Write the letters and the values. All for a stick of gum. And then the values.
Okay.
It's technically 8:17. It's very slow. And it still says 8:17. Now, this is what we'll need to know. Okay? Very nice. This is what Sam usually digs into. Grab one, throw it back. All right, so make sure that you know this, not for today, not for tomorrow, but for Wednesday. Thank you. Okay? So when we look at things, don't freak out and go, oh, there's no way I'm going to memorize that. I know. Now, I actually posted this up here vertically, but you guys can see that it's a lot easier to memorize it that way or on the horizontal. A couple things to note about this. Make sure that the K is lowercase. I'm not going to go crazy on you right now or this week, but the K is lowercase, the D is lowercase, the C and the M are lowercase, as is the N and the P. So really there's only 3 capitals, because one reason why we want to make sure that we're not making it uppercase or lowercase, or we want to be very specific with that, is because this represents for milli, where this one represents for mega. So if I were going to give you a paycheck of, say, a mega dollar versus a milli dollar, you want mega dollar, which is a million. So just be aware of that. And don't forget, the great Mega King one day caught me microwaving nasty pizza. Okay. All right, now, also, and here's our final practice problems, and we're going to be done here in a second. On this side, you'll notice that the exponent is positive and a big number. Over here, it's negative and a really small number. Now, negative 12 is a lot smaller than positive 12. So when we look at or compare, like in the practice problems here, if I ask you which is bigger, a gigagram or a centigram, the one that's farther to the left is larger. Make sense? And then vice versa, if we're looking for smaller, the one that's farther to the right. Okay. So let's look at the practice problems. And you can leave this up. I'm going to actually scroll this over. So, kilometer or centimeter? Which one is bigger or larger? Kilometer. Or kilometer, if you want to say it that way. Which is bigger, a picoliter or a milliliter? Milliliter, yeah. So pico, again, is off to the side here, negative 12. Pico, and then, what was it? Milli. Oh, here we go, there. Okay. Megagram or microgram? Mega's bigger. And then number 3 is asking which one's smaller. So which one's smaller, a nanometer or a centimeter? Nanotechnology. And then which one's smaller, a micro or a milli? Micro. Micro, again, is that backward U with a tail thingy on it. So that's micro. Okay. And let's see here. Is the last one centigram, kilogram? Yeah, so which one is smaller? Centigram. Okay. And then the homework are the 2s. So the 1s and the 2s. Might take you 5 minutes to do it. Maybe. Okay. Questions on what we did today? So here's your homework, the 1s and the 2s. Also, be sure that you know, make sure that you know this. Okay. Now, I'm not so worried about you knowing tera, giga, mega, all those guys yet, but I definitely want you to know the factor, and I want you to know the prefix. Okay. We will learn this as we do the homework. Okay. So if I refer to a milligram, you'll know, oh, yeah, milli's down there. Okay. But if you're learning this ahead of time, then life is good. But you've already got the pattern down, or you should. The great Mega King one day caught me microwaving nasty pizza. Okay. And if you wanted to, I think it's on the last page, here are all of the different types, but we don't necessarily use them all. So if you wanted to be a geek, and I think, is Google 10 to the 100? I can't remember what Google is, if it's 100 or 1,000.